All right, let's get started with this worksheet talking about projectile motion. And the key to remember is the two different components. We're going to have a horizontal component and a vertical component for each of these problems. Remember, the horizontal is across the horizon, the vertical is up and down. So let's get started. So this first one, we have an object projected horizontally with a speed of 15 meters per second. So in the horizontal, we know that our velocity is equal to 15 meters per second, and the object falls a distance of 200 meters. So falling implies the vertical. So we know that our vertical distance is going to be 200 meters. So the first question, how long does it take for the object to hit the ground? Well, that would imply figuring out, if we drop something from 200 meters tall, how long does it take to hit the ground? Well, we know our reduced simple formula for time for a free-falling object is the square root of the distance divided by 5. So we'll just plug that in there. So for A, we have time is equal to the square root of our distance, 200, divided by 5, which is going to be the square root of 40, which we're going to have 6.32 seconds. Okay, so it took 6.32 seconds for the object to hit the ground. Well, at the same time that this object is falling for 6.32 seconds, it's still traveling horizontally. So let's take a look at our horizontal stuff. We know how far. We know that distance is equal to velocity times the time. So for part B, we have distance is going to be equal to our velocity, 15 meters per second, times the time that it was falling, 6.32 seconds, is going to give us 94.86 meters, was how far it went along the horizontal component. All right. Now let's take a look at the next one. Same kind of thing. So we have an object that's launched from 650 meters high. So again, that's going to imply vertical. So we know our vertical distance is equal to 650 meters. The object has a range. Okay, so now we're talking about horizontal range or horizontal distance. So now the horizontal distance, it flew for 475 meters. So same question, how long does it take for the object to hit the ground? We're going to use our same formulas here, distance divided by 5. So for part A, we're going to do it the same way. Time is going to be equal to the square root of 650 divided by 5, which is going to be the square root of 130, which is going to come out to equal 11.4 seconds. Okay? So that's how long it takes for the object to hit the ground. Now, the second question, how fast was it moving in the horizontal direction when it left the cliff? Okay. Well, if it traveled 475 meters in 11.4 seconds, we know how fast it was going because we know that velocity is equal to distance divided by time. So for question B, we have that velocity is going to be equal to, oh hey, how about we introduce our happy dandy object here, the Sharpie. Let's make the Sharpie the word of the day. There's your secret word of the day, kids. It's Sharpie. So let's get back to this now. So we have our velocity, which is distance divided by time. So we have our 475 meters divided by our time of 11.4 seconds, giving us a grand total of 41.66 meters per second as the original velocity heading off the cliff. All right, hope that helps, and we'll see you later.